All right, so we're talking about boiling point, and we defined boiling point as when the vapor pressure is equal to the atmospheric pressure. And at sea level, we know that water boils at 100 degrees Celsius, where the atmospheric pressure is 1 atm. Now, on Mount Everest, we've said that the atmospheric pressure is lower. And we just looked it up, and it actually equals 0.333 atms. So we know that's a substantially lower. So what happens to the boiling point then? It's going to go way down. Is it exactly a third? I can't actually tell you because I don't know that formula. It might be, it might be a little different. There might be other things involved other than the pressure. I don't actually know. But yeah, it would boil at, let's say 50 degrees Celsius, because there might be other things involved. So let's say approximately 50 degrees Celsius, right? So imagine you're up on Mount Everest at the base camp or something, right? The last base camp, and you're trying to, it's freezing, right? Because it's really cold, and you're trying to make your food, and your water is boiling, it's bubbling, but it's 50 degrees Celsius, right? Which is like 130 degrees Fahrenheit or something. So it's not even warm. Does that make sense, what I'm saying? But it's boiling, it's bubbling, and that's as high as it's going to get. Because remember, you're not going to get your water to get any hotter than that, because what's happening when it's boiling? Lucas? Yeah, it's vaporizing, right? So they make contraptions and have for years, right? This is not a new contraption like, in the 1990s. No. This has been going on for years because they've been climbing Mount Everest for decades, for, hundreds of years, right? For 100 years. So they make contraptions, pressure cookers, that keep the boiling water under pressure so that they can raise that temperature higher. And so they keep it under a certain pressure so that that temperature will keep climbing so that you can get a hot cup of water for your food, so you can still eat hot food. All right? But you can see that the boiling temperature drops substantially. So let's talk about what boiling actually is and why this happens. So if I have a pot of water, okay, and in here is water, my atmospheric pressure, right? So this is my atmospheric pressure. It's my column of water is pushing down on the water, right? Sitting on top of the water, yeah? And now I have fire underneath here, and it's purple. There's my fire. Okay, and it's heating the water. And the water is gaining energy. And then what the water wants to do is it wants to jump out of the pot. It's gaining energy. And what the water wants to do is it wants to jump, the particles want to gain energy and jump out of the pot to become gas. So essentially, what they have to do is they have to gain enough energy to jump out of this pot and leave the pot and float away. Now remember, temperature is defined as kinetic energy. Right? So if the atmospheric pressure is high, they need a lot of kinetic energy to overcome that high atmospheric pressure. If the atmospheric pressure is low, they don't need as much. That is the bottom line. Okay? So, the lower the atmospheric pressure, the less kinetic energy the particles need to change phase. Does that make sense? And that's how it works. So the lower energy, because kinetic energy is temperature. That's how it works.